Hi, welcome to Microsoft Build 2018. I'm Jeff Sakowitz, a program manager on Microsoft Graph. In this video, I'll provide a detailed look at our permissions and consent model. I'll start by explaining what Microsoft Graph is to help give you some context. For the rest of the video, we'll do a deep dive into our OAuth permissions and consent model, with a specific focus on how they relate to Microsoft Graph. I'll start with an overview of the model, and then dig into some best practices and troubleshooting tips. So what is Microsoft Graph? If I were to give it a textbook definition, I'd say that it's a unified REST API and comprehensive developer experience for integrating with the data and intelligence exposed by Microsoft services. But what does this actually mean? Microsoft Graph is your one-stop shop for accessing data, relationships, and insights across Microsoft 365. It's a REST API that lets you build rich applications that integrate with services used by over 100 million active users. These services include Azure Active Directory, SharePoint, OneDrive, Outlook, Teams, Intune, Windows, and more. There's also some exciting new security APIs, and even APIs built specifically for the education space. All in all, there are over 8 trillion resources available in Microsoft Graph. Now let's talk about permissions and consent. As I mentioned earlier, we'll be focusing on how this model applies to Microsoft Graph, but the concepts here are pretty generic and can be applied to other APIs you might be integrating with as well, at least the ones that use our OAuth and Common Consent framework. Let's start by going over some of the terminology. First, we have the client, which is the application that is requesting access to data. This data will be exposed by a resource, which is generally a web API like Microsoft Graph. This resource will also expose a number of permissions, which grant the client the ability to perform some action on some data. An example of this is the ability to read a user's OneDrive files through Microsoft Graph. These permissions to access data are not something the application developer can just obtain on their own. They need to get consent from the owner of the data first. This usually happens through a consent prompt, where a user will be asked to grant the client access to some data exposed by the resource. When a user clicks yes or accept on the prompt, this results in a consent grant being recorded. Sometimes this is performed by an administrator, either when the app is requesting admin-restricted permissions that only they can consent to, or when an admin wants to consent on behalf of the entire organization. There are two main permission scenarios. The first is where the app is getting access on behalf of one or more users. This is usually the case for mobile, web, or single-page apps. These apps generally use delegated permissions, which also might be referred to as app plus user permissions, scopes, or simply user permissions, depending on who you ask. Users can usually consent to delegated permissions that grant access to their own data, but admins will need to consent for higher privilege delegated permissions. Admins can also consent to delegated permissions on behalf of the entire organization. When working with delegated permissions, the effective permissions, or what the application can actually do, are calculated by taking the intersection of what the application has been granted via consent and the permissions that the user has in the underlying system. This prevents against any elevation of privilege. For example, if an app gets consent to do full CRUD on all users across an entire organization, but it's making calls on behalf of a non-admin user who cannot normally delete users, the app won't be able to delete any users. It would only be able to do so if an admin user has signed into the app and the app is acting on behalf of that admin. The other scenario is the case where the application is getting access as itself, or in other words, as a service. Apps that operate purely in the background, otherwise known as daemon apps, fall into this category, along with other highly trusted subsystems. These types of apps will request application permissions, and are also known as S2S permissions or app-only permissions. Only administrators can consent to most application permissions, and the effective permissions are exactly what the application has been consented to do, since there is no signed-in user present for the app to act on behalf of. Most permissions Microsoft Graph exposes are formatted with a resource prefix, which represents the target entity that the app is requesting permissions to access. Next comes the action portion, which usually indicates whether the app is requesting read or read-write privileges, although there are some exceptions. Finally, there's an optional suffix that indicates the scope of the permission being used, not to be confused with OAuth scopes or delegated permissions. Usually, this will either be .all, indicating the permission is used to request access to all entities of a given class across an entire organization, or not present at all, which infers the permission is specifically targeted to the signed-in user, although there are some exceptions here as well too. A few examples of delegated permissions include user.read, which is a permission that allows the app to sign a user in and read their profile, and notes.readWrite, which is a permission that allows the app to read and write all of the signed-in users' OneNote notebooks. Files.readWrite.all is an example of a highly privileged application permission, which allows an app to do full CRUD on all files across the organization without a signed-in user. This is a powerful permission that requires administrator consent, and this sort of thing should only be requested when absolutely necessary. It's important to understand what permissions are right for your scenario before requesting them, so be sure to check out our documentation. There's a dedicated article that guides you through selecting permissions, and each one of our API reference pages will also tell you what specific permissions are required to call that API. Now let's talk about when consent is actually prompted for. Usually this happens automatically the first time someone uses an app that requires permissions to access resources that are protected via OAuth. This can also happen if the app is coded to explicitly prompt for consent, if the permissions the app is requesting access to have changed, if the user revoked consent and went to use the app again, or if the app is using incremental consent to ask for some permissions up front and more later. So this is not always unexpected. Speaking of incremental consent, it's important to know what this is and how it relates to a few other flavors of consent, static and dynamic. Static consent is the term used for the scenario where the permissions in the consent prompt come from a pre-configured list that was specified by the developer up front. Static permissions are configured by either selecting certain permissions in the app registration portal or by specifying them manually in the required resource access section of the app manifest. Static consent is the only option when working with the V1 endpoint. There's just a single set of permissions that will be prompted for every time the user needs to ask for consent in V1. In the V2 endpoint, dynamic and incremental permissions are an option as well. Dynamic permissions are used in the scenario where the application specifies which permissions it's requesting directly in the call it makes to the authorized endpoint. These permissions are usually specified in the code of the app as well, and this is how it is in most of our samples. There's a special case to be aware of where the .default scope can be used. This tells the authorized endpoint to look at the list of static permissions in required resource access that were specified in the portal, even though the app is using the V2 flow that is normally dynamic. Incremental consent is a subset of dynamic consent. This is where the application asks for some base set of permissions up front and then it asks for more later as needed. This is really useful for apps that require a small handful of permissions for their basic level of functionality, and then need more later for optional features or capabilities that a user might not use right away or not use at all. All right, so now let's move on to some best practices in troubleshooting. First things first, always abide by the principle of least privilege. This means that you should only request permissions that are absolutely necessary, and only at the moment when you need them. Remember that you're asking for permission to access sensitive customer data here. In general, it's really important to be thoughtful when you configure your app, especially around consent and permissions. This can improve your app's adoption by customers, and it can also help tighten up your security posture in case something goes wrong. For example, in addition to abiding by least privilege, it's important to choose between delegated or application permissions based on your scenario. Putting yourself in the customer's shoes is also very important, especially when you're building a multi-tenant app that will be available to many users across many organizations. Here you need to think about all of the different controls and policies that might be in play in all of those cases, and make sure you test your app's configuration across all of those potential scenarios. And we'll talk about some of the gotchas in a moment. When a given issue comes up in the area of consent and permissions, the exact solution will vary quite a bit depending on the specific situation. It's important to take a step back and understand what is going on before implementing a solution. These generally aren't issues that should be approached with a standard break-fix mindset, where you can just try a bunch of different things until the issue is resolved and then move on. Even though the strategy might get rid of the specific error you're seeing at the moment, it could lead to much bigger issues down the line. For this reason, the first thing to do when you encounter an issue is to take a step back and frame the problem. and this all starts with the scenario. First and foremost, you want to think about what the goal is of the app or the piece of functionality that you're having problems with. You want to ask questions like, what data does it need to access and for what purpose? You want to look at what error you're seeing and where it's being thrown. Is it coming from the authorized endpoint, the token endpoint, the actual API call, or somewhere else? Who's using an app? Is this an end user or an admin? If we're talking about Azure AD users here, what consent and app access policies might have been applied in that organization? Next, it's important to think about the application itself. Is it using a client library? If so, which one? Is it targeting the V1 or the V2 endpoint? What protocol flow is being used? Is it using static, dynamic, or incremental consent? If you don't know the answer to these questions and didn't build an app initially, it'd be good to get that information from the person who did. It's going to save you a lot of headaches and troubleshooting down the line. Finally, it's good to think about the resource that's being targeted. What API or APIs are being called? What permissions are being requested from these APIs? Are they right for this scenario, or are there others, possibly less privileged ones, that should be used instead? To get more specific, one of the more common issues we see in this space is when a developer is getting a 403 unauthorized unexpectedly when they actually expect all of their calls to succeed. In this case, it's important to understand what permissions have been requested, consented to, and who consented to those permissions. It's also good to know whether these things actually map to the specific call the app is making, which is failing. It's also good to think about the effective permissions in play here. If the app is using delegated permissions, the call could be failing because the user who the app is acting on behalf of doesn't have permissions to take that action in the first place. In some cases, there isn't much you can do about that as a developer. If a tenant admin has blocked users from reading each other's profiles, for example, a 403 would be expected when an app tries to take that action on a user's behalf, and apps will need to respect that admin's configuration for their tenant. So not all 403s should be considered unexpected or bad. Another thing we see people struggle with is the case where a user isn't able to consent to an app. This could happen if the app is requesting that a non-admin user consents to admin-restricted permissions, or if the user's admin has blocked end users from consenting to apps altogether. In either case, an admin will need to consent in order for any end user to use the app. One more issue we see on occasion is the scenario where an admin has consented to the app, but end users are still blocked from using it. One common cause here is when a developer is using the V2 endpoint and has configured a very small number of static permissions, or just left the default one of user.read selected in the portal, but is asking for a larger or completely different set of permissions dynamically or in their code. In this case, an admin does consent to the app on behalf of all their users in the organization successfully, but they're consenting to a different set of permissions than the app is actually asking end users for at runtime. This can be solved by ensuring that the list of static permissions an application asks for are always a superset of the permissions an app will be requesting dynamically or incrementally. However, this doesn't mean you should go and request all available permissions statically. Stick with least privilege and only ask for those you'll actually be using. One last gotcha is the scenario where an admin requires that users are assigned to applications before they can sign in. This requirement holds true even if consent has occurred, so as long as this is set, the admin will need to go and assign each user that they want to have access to the app even after consent has occurred. If you're having one of these issues and need to post on Stack Overflow or open a support case to get help, there are a few things that can be helpful to include in that request to expedite the process. These include the scenario and the goal, the error code and the exception text you're seeing, the timestamp, and a correlation ID or tracking ID GUID. To wrap things up, always abide by the principle of least privilege. Only ask for the permissions your application absolutely needs when it needs them. Also, be thoughtful when requesting permissions and consent, and when configuring your application in general. And make sure to be scenario-driven. Consider all personas and possible customer configurations. To learn more, check out our documentation at graph.microsoft.com. Also, make sure to check out our samples on GitHub and tell us about what you're working on Twitter. If you have any questions, make sure to post them on Stack Overflow using the Microsoft Graph tag. Thanks for watching.